begin talking about simplifying radical expressions. When I say begin, we have to understand that it's actually a review. We might expand a little bit on it, but most of what we're doing today, you've done before. And it's time that we get better at it, okay? So we have to understand what like radicals are. Like variables. Like variable would be the same variable with the same exponent. Like radicals must have the same index and the same radicand. And then I drew a little picture here to remind you of what the index and radicand looks like. Where to find it. So we have a couple examples here. All right, so this first example, the question is, are these like radicals? Are they like radicals? Do they have the same radicand? Do they have the same index?
Yeah.
Yeah, what is that?
3 square roots of 2. Oh, is that what you're asking?
Yeah, I mean, what is the index and the radicand?
The index is 3 and the radicand is 2.
So we're talking about the cube root of 2, right? And so we can add these two together. How many do we get? 3 cubic roots of 4? No. Let me ask you this. If I had this, what would you get?
4x.
4x, right? I didn't change my x to 2x or x squared or anything else, right? I have 1x plus 3x's is 4x's. So what do I get now looking at this example?
4 cube root of 2.
Yes, I have 1 cube root of 2 here, plus 3 more cube roots of 2 gives me 4 cube roots of 2. Okay? So treat the radical like it's a variable. And then I always used to tell you, treat the variables like they were apples or oranges or pears or something like that. And you ask yourself, I have 1 apple plus 3 apples is 4 apples. Here I have 1 apple plus 3 apples is 4 apples. Okay? How about example 2? What do I get when I add those two?
Because they don't have the same index, can you compare them?
The question is, since they don't have the same index, can I compare them? Do you mean by comparing them, you mean can I add them?
Right.
Good question. What do you think about that?
Probably not.
Who said probably not?
I didn't.
Mason?
There's no index.
There's no index. So what is the index?
Would be 1?
No.
It'd be nothing. 2 0.
It'd be a 2, wouldn't it?
Well, because it's squared.
It's a square root, and if there's nothing there, it implies a 2.
Oh, squared.
So 1's a 3, 1's a 2. Are they like radicals?
No.
No. So can you add unlike terms?
No.
No. And so this is the answer. There's no simplifying can be done to that. Okay, that's as far as you can go. Okay? How about this one? Example 2b. Five square root of 2 plus square root of 18. And I add those together. Danny saying yes? Maddie said yes too.
You have to announce it to the world.
I didn't, just to the class.
Oh.
I could call the radio station and know it's not there.
Maddie said yes.
They might interpret that a little differently. Yeah, I won't do that. Good call, I won't do that. All right. So Danny, you said yes, why?
Because there's only a square, or there's a square index on both of them, sorry.
I'm sorry, what's that?
There's a square index on both of them.
Oh, so it's square root on both of them?
Mm-hmm.
Okay.
They don't have the same radicand.
Yeah.
Do they have the same radicand?
Just
No.
kidding.
I said no.
To be.
I said no.
What do you think, Sid? Can we add those together? Okay. Let me ask it this way. Could we change one of those so that we could add them together? Well, you're right on. Both of them today. What is 18? Square root of 18 is equal to what? Louder? 9 times 2. What's the square root of 9? So isn't the square root of 18 equal to 3 square roots of 2?
Yeah.
Yes, it is.
Oh, so I was right.
Ah, so you were right.
Guys, I said yes.
Just for all the wrong reasons. Yes. So the question is, what is 5 square roots of 2 plus 3 square roots of 2? What is it? 8 square roots of 2. Okay, I agree with that. So here's a tip. When you have something like this and they're not the same, take a peek at the prime number and ask, is there any way I could make this number look like that? And so, the only way I could add them is if 2 is a prime number, right? If I could make that look like a square root of 2, okay? So, let's throw another one in here. Square root of 8 plus the square root of 27. What? This would be 2c. You think I can add those? Is 8 times 3 27? No, 8 times 4 is 20, right? 8 times 3 is 24.
Oh, no, Ryan.
Okay?
I know I'm
No.
Now, how do you get 8?
4 times the square root of 4 times 2.
So square root of 4 times square root of 2. How do you get 27?
Square root of 9 times
Square root of 9 times square root of
3.
3. Well, square root of 4 is 2. And square root of 9 is 3. And so the question is,
probably not.
can I add those together now?
No.
They have the same index, right, Danny?
Yeah.
They do. They're both square root, but they have different radicands, don't they? And they're both prime. 2 and 3 are both prime numbers, meaning I can't simplify it anymore. Right? If they weren't prime, then I could consider, do they simplify more? But once they're a prime number, then they won't simplify anymore. And so I cannot combine these anymore. But if their directions say simplify, this is the answer they're looking for. So you would simplify the 8 and 27 into 2 square root of 2 and 3 square root of 3. But you can't add them together any further than that. Any questions on that? All right, moving on. What are conjugates? We've dealt with conjugates already, so this is one of those concepts that's review. What are conjugates? Let me ask it this way. What's the conjugate of x plus 3? It's not 3. X minus 3. Who said that? Nice, Mason. That's twice today. So
I'm
the
betting
conjugate
zeros.
of x plus 3 is x minus 3. Okay? What's the conjugate of 3 plus square root of 2? 3 minus square root of 2. Okay? What's the conjugate of 4 square root of 3 minus 3 square root of 5?
4 square root of 3 plus 3 square root of 5.
Okay, 4 square root of 3 plus 3 square root of 5. So, what can I say the conjugate is then?
The thing that changes what joins the numbers.
You change the sign.
Yeah.
Okay?
The,
So the rule I gave you a long time ago, does anybody remember it now? Same conjugate has the same numbers, but different sign. That's what we said before. Conjugates have the same,
can we put equation instead of numbers?
number. Well, you would write expression.
That's
Same numbers, but different signs. Okay, same numbers but different sign. That's conjugates. It's important we understand that because we're going to use that here in a couple minutes. And before we jump into that, let's deal with this first one here. We just want to multiply. Okay?
Is this a conjugate that we're supposed to do? Or?
These are not, the number 3 is not conjugates, are they?
Well, I wasn't sure. 'Cause
They're
we
not
were
the
just talking
same
about
numbers,
conjugates
right?
and numbers.
We will, we're gonna lead into that. But I didn't have that step in my notes until I looked through it today. And I didn't wanna take time to rearrange everything on this page, so I just threw a new page in there to remind you what conjugates were before we got to them. So, how do I multiply two binomials? FOIL. Right? I FOIL. Good. And so F in FOIL stands for first two, so what's 2 times 1? 2. O stands for outer 2, so what's 2 times negative 5 square root of 3? Negative 10 square root of 3. Okay? When you multiply the outer numbers together, and then you just show all the radicals next to it. So it's 2 times 5 square roots of 3. It gives you 10 square roots of 3. I stands for the inner 2, plus or minus? Plus. 4 square root of 3 times 1 is 4 square root of 3. And L stands for the last 2. And so what's 4 times 5? Negative 20. And what's square root of 3 times square root of 3? Square root of 9, right? What is square root of 9? 3. So this really becomes 3. And so we get 2 minus, well, let's do this. What's minus 10 square roots of 3 plus 4 square roots of 3?
Negative 6.
Negative 6 square roots of 3. And what's minus 20 times 3? Minus 60. And so can I simplify any more? 2 minus 60 is? Negative 58. Minus 6 square roots of 3. Usually you write the whole number, I shouldn't say whole number, but the integer first, and then you'll write the constant, no, I can't say it that way. The integer term is usually written first, and the radical term is usually written second. Okay? So the answer to number 3, the most simplest form, is that. Questions on it? Okay. Now, what do you notice about number 4? What are they?
Conjugate.
They're conjugates. Because they have the same numbers, 3 and square root of 7, but they have different signs. One's plus, one's minus. Okay?
Get closer.
We're going to pretend we don't know anything about that right now, and we're just going to multiply. How do I multiply binomials? FOIL. And so what's the first two? 3 times 3? 9. And then the outer two, 3 times negative square root of 7. Is that negative 21? Square root of 21? Say no. Say no, that's not it. They're not both inside a radical, are they? When you're multiplying, you multiply the numbers that are outside the radical together, and then you multiply the numbers that are inside the radical together. But they're one of each, you simply just rewrite it as 3 times square root of 7. Okay? The inner two is again 3 times square root of 7, which would be a plus 3 square root of 7. And the last two is square root of 7 times square root of 7, which is what? Negative. Negative square root of 49. What is square root of 49? 7. What happens to my minus 3 square roots of 7 and my plus 3 square roots of 7? They cancel. And I'm left with 9 minus 7, which is 2. So now let's think about what just happened here. When we multiplied the conjugates, what happened to my O and I? They cancel. That's going to always happen. A plus B times A minus B. A times A is A squared minus AB plus AB minus B squared. What happens to minus AB plus AB? It cancels. Every time you multiply conjugates together, the middle two and the outer two will always cancel, leaving you with the first one squared minus the second one squared. This is what we call the difference of two squares. Remember that? And when you were asked to factor the difference of two squares, we always got this, which was the conjugates of each other.
But we didn't square them. So
We're going the other way now. They're giving it to us as conjugates, and we're multiplying them. And so what I hope you realize, if I write 3 minus square root of 5 times 3 plus square root of 5, I'm hoping you can go directly to this. What's going to happen with my outer and inner two? They're going to cancel. A squared means the first two multiplied together. What's 3 times 3? 9. Minus B squared, which is the last two multiplied together. What's square root of 5 times square root of 5? Square root of 25, which is 5. What's 9 minus 5? Okay, so anytime you multiply by a conjugate, all you really have to do is multiply the first two and the last two, because the outer two, inner two are always going to cancel. Do I have a radical sign in my answer? Did I have a radical sign in my answer? Do you think I'm ever going to end up with a radical sign in my answer? No. When you're multiplying conjugates, you lose the radical. When you multiply conjugates, you lose the radical. That's what's important about what we're going to do next here. We're going to multiply. Remember, if you took 2/3 and multiply by 1, what would you get? 2/3, right? If I took 1,000,000 and times it by 1, what would I get?
Still get a million.
I'd still get 1,000,000. What if I took 2/3 and I times it by 3/3? What would I get?
2/3.
Well, no, I would get 6/9. Now, it has the same value as 2/3, doesn't it? That's the point we're getting at. We can change the way it looks, but we're not going to change what it's equal to. Those two are still equal to the same number because anytime you multiply by 1, you haven't changed the value. It's important to realize that because what we're going to do here to rationalize the bottom, the denominator, remember rationalize means get the square root out of the denominator, we're going to multiply by the conjugate, 4 minus square root of 3. But if we do that to the bottom, in order to keep them equal to the same number, we have to do it to the top. Because what's 4 minus square root of 3 divided by 4 minus square root of 3? Still 1, isn't it? Okay? The bottom here is going to be the easy part. Because they're conjugates, what we just learned is going to happen.
The sign will be changed.
Okay? But when I multiply my conjugates, what's going to happen? What's canceling? The radical. What terms will cancel? If we think about foiling, what terms will cancel? Outer 2 and inner 2. So all that's left to do is what? Multiply the first two. What's 4 times 4?
16.
Minus, it's always got to be a minus. Multiply the last two. What's square root of 3 times square root of 3?
81.
No. It's 3. Square root of 9, and the square root of 9 is 3. So now when I do the top, are they conjugates? No. Can I just throw out the O and I? No. So now I have to FOIL the top. What's 2 times 4? 8. What's 2 times negative square root of 3? Okay, minus 2 square roots of 3. What's negative square root of 3 times 4? Minus 4 square roots of 3. What's a negative square root of 3 times a negative square root of 3? Positive square root of 9, which is positive 3. Okay? So if I simplify, 8 plus 3 is 11. Minus 2 square roots of 3 minus 4 square roots of 3 becomes what? Minus 6 square roots of 3. And then 16 minus 3 is 13. Okay? This is my answer. Now, 11, 6, and 13, other than the number 1, do they have any factors that are the same? No. I asked that because had you ended up with an answer that looked like this, six, 12, and 6 all have a what in them? A 6. So when that's the case, you can divide a 6 out of every term. And so 6 divided 6 is 1. 12 divided 6 is 2 over 1, which is the same as 1 minus 2 square roots of 2. So you can simplify. If they have a common factor, you can divide it out. Now maybe the whole number doesn't, maybe you can't divide the whole number out. Maybe there was a 16 there instead of a 6. And you'd say, well, every one had a 2 in it. And if that was the case, then I would get 16 divided 2 is 8, 12 divided 2 is 6, and 6 divided 2 is 3. Now the 8, 6, and 3 don't all have something in common. The mistake is people look at this and say, oh, 6 and 3 divides into 2. Well, that's true, it does, but 8 doesn't divide by 3. And so we cannot simplify that any further unless every term has that same factor in it. So when you get to here, you would stop. Okay? Any questions on that? Okay. That's it for the notes. Let me grab my book and tell you what you're saying. So there's your assignment for tonight. And one thing you need to know. Tomorrow we're going to take a quiz.
A homework quiz?
It may have homework questions on it.
No.
It will also have other questions on it over lessons 7.1, 7.2, and this one, 7.3.
I'm not ready for homework.
At the beginning of class tomorrow, I'll answer some questions. We're not going to do new work tomorrow. So I'll answer some questions at the beginning of class, and then we'll take our quiz. Okay?